In this race to self-driving cars, how far behind are other automakers from Tesla? When people heard that NVIDIA is now partnering with 17 automakers, including Toyota and BYD, their first thought was that this means every car maker will now have robotaxis and autonomy. But make no mistakes about it, this is not some snap-together solution. These are starter kits, and more likely than not, Toyota will end up on proof-of-concept island instead. And while legacy automakers are playing catch-up, Tesla's far, far ahead. Tesla's now talking about a truly connected car, a vehicle that remains connected to the internet at all times via high-speed connection, and what possibilities might emerge involving Tesla's full self-driving. Soon enough, Tesla cars will be able to see ahead and learn from each other. Traffic can be directed, and the cybercab experience can be enhanced. While Tesla is able to showcase these new software features, what will it take for other automakers to follow suit? Today, we have a very special treat to have Phil Beisel join us. Phil was a founding member of the technical team at Rivian, an electric vehicle maker. He led several key projects, including vehicle UI, mobile, and cloud. Before Rivian, he held various engineering management roles at Apple. Welcome, Phil. Thank you for joining me yet again.
Happy New Year.
You are literally one in a handful of individuals on Earth that can explain this really, really well. What does it take for automakers to install not only software, right, but they need to install, these features, autonomy. So, you did two incredible posts. If you haven't followed Phil yet, follow him on X. And he did a fantastic post explaining, how people misinterpreted what they heard about NVIDIA and what it takes for an automaker to actually, add in full self-driving. Why don't you share what you're thinking there?
Yeah, sure. I approach this from kind of a first principles of engineering mindset. This is the kind of team we built at Rivian is a set of really, high power kind of engineers that really could build anything, both on a hardware side, software side, and build a truly vertically integrated stack, from literally selecting chips to building the ECUs to bootstrapping the right OS, embedded OS on the systems, and building building the software solutions on top. And, that takes a really special organization. It takes, I like to think that it takes a Silicon Valley organization. I mean, it's not necessarily exclusive to Silicon Valley, but honestly, if you could probably count on your hands the number of organizations outside of Silicon Valley that do this kind of work. So, if you look at what's going on here, NVIDIA is doing exactly the right thing. I mean, it's really amazing what they are doing, but their announcement really wraps around the idea that they're going to build this sort of software development kit reference platform and hand it to legacy automakers and expect that somehow magically FSD is going to pop out the other end. And that's not going to happen. I mean, it's not even close to what's going to happen. And I think, what you said in the intro is that what will happen with legacy is they'll end up what I call proof of concept island. They'll build something that sort of works through a bunch of cases. They'll be very excited about. They'll show management, but they won't really have the chops. Maybe that's really what this part of the conversation is about. They won't have the chops from an organization point of view to really go deep and build the right engineering solution. And what's interesting about this is I was thinking about this the other day, and I think that there's a lot of people who don't understand what it takes to engineer these types of things, and it's getting harder to understand, right? Because AI is making it sound simple.
Mhm.
What AI has done is said, well, all you do is pour data in one end, you train this thing called a neural net, and out pops this model, and then you just apply some magic thing called inference, and the car drives itself. And I think what actually the truth is it isn't. And what you hear is, oh, you don't need a bunch of engineers coding the solution anymore, right? Less engineers writing code. Like the AI, when Tesla moved from version 11 to version 12, they made a big leap. It was almost a step change in what they did, and they went to a full AI model. And they removed. You remember this conversation where they talked about the planning side was like 300,000 lines of carefully crafted C++ code, and so they removed that. And I think what people think is they say, oh, wow, they removed that. And therefore, they don't need the expertise to build that. They just let the AI train and build that. But I got news for people. It's actually
Mm,
harder now. It's gone the other way. In the middle, this thing that you decide that you're going to train, this model you're going to train, is requires a lot of engineering thought. And maybe it's more architectural, certainly not code because you're not writing code, but you've got this whole thing you have to decide, okay, what kind of data am I going to use? What's my, how am I going to parameterize my model? How big is it? What does it look like? What is it supposed to do? What am I training the functions to do? Um, and I think that middle part requires a very, very uh, high-end engineering organization to accomplish that task. So if you think you're just going to be handed a toolkit from NVIDIA and you're just going to run through data through it, come out, build a model and run it on inference, that's not going to happen. You will end up with something, but what it won't be is it won't be anything that is a viable product in the market. It'll be something that's really a proof of concept, um, and leads you down the path that, you know, I mean, what it's going to do, interesting, is I think it's going to leave you wanting. You're going to be saying, oh, I think it's better if we just go and try to approach Tesla and license FSD. Because the problem is you're never going to be able to build the type of organization, at least in my opinion, you're not going to be able to build the type of organization that's going to be able to take that to the finish line. And I think we've
mm,
learned, with FSD, the finish line's the hard part, right? You get this thing started and people say, oh, I can drive around the block. And then all of a sudden, all those little
mhm.
cases start to show up, the long tail of cases in driving, which is like one of the longest tail problems I know of. And all these things have to be addressed and dealt with, and the models have to be fine tuned. This takes really, really smart people, like incredibly smart people. Um, like I wouldn't even almost know where to start to solve this problem. And Tesla's built this team over, almost a decade, right? They've built this incredible team that has developed the technique. Like I think an AI model is a reflection of a technique.
Mm.
It's like, what do you imagine you want that to be in terms of what it does with that data? And that's what you're tuning that training of that neural net to be, right? And if you're just doing it without any kind of thought, you're not going to end up with something that's going to really be problem solving. Yeah.
Yeah.
So I think from NVIDIA's point of view, this is great. I mean, this is what do you do? No, it's great. I mean, what do? You sell a bunch of hardware to Tesla. Tesla does amazing work. They leave the entire world wanting. Then NVIDIA comes in, builds sort of a lightweight version of that, like an SDK, like a software development kit, reference platform type of thing. Get you excited about it. A Toyota buys potentially $1 billion of hardware from NVIDIA. They don't quite get there. Then they're told, well, they just don't have enough data, so you need to buy more hardware to do generative AI simulation. And they just keep repeating themselves. And then as Tesla buys more and raises the bar, all that the legacy makers can do is just buy more, right? Or decide that they don't want to be in the game. And ultimately, I think that's where they're going to end up. They're going to say, we can't solve this problem. And I'm not saying other companies can't solve the problem. You could do this, but you really have to start and develop the kind of what I call A plus plus team that Tesla has. Um, so yeah.
Yeah. I appreciate that intro, Phil. Of anybody on Earth, you ran the software development team at Rivian.
Mhm.
You had given this a lot of thought. You created that team. You knew that you need to be software first, not just an EV first kind of company. And then, you're giving advice to these automakers that if they wanted to do this, they need to build a team first. And it's not just like you called it, just snap on technology
Right.
then they're going to
Right.
end up in this what you call proof of concept island kind of scenario because it takes a lot more. It takes an engineering management team. I really appreciate that. Tell me more about what you think the OEMs should be doing because they're at the moment. Like, many of them will be seduced, right? And goes, I'm just going to go out and buy NVIDIA
Mhm.
because they seem to have the path here, versus making the decision to partner with Tesla's FSD. And you're kind of saying, hey, if you go down this route, it's not just snap together. You need to consider this. What should they be thinking about before they make that decision?
Well, I think they have to commit at a leadership level in the organization of what they're trying to do. Like, I think that's
Mm,
the number one thing I think is that when I worked at Rivian, the beautiful thing about working at Rivian was the CEO committed to building a software stack in a first principles way. He understood it
right.
intrinsically, smart man, and he committed to it. And I think, you know, both parts are necessary, right? The commitment is really hard. It takes a lot of effort. I mean, we spent years working on a stack, and we're not talking about solving FSD here. We're talking about the whole, software defined architecture of the Rivian. But um, so there's this thing called leadership that is so incredibly lacking in a lot of these companies. They often build these groups. Like, I've seen these satellite groups where Porsche or wherever will have a group sitting around in Palo Alto. They'll situate themselves in Silicon Valley, but it will be kind of an R&D group, and they'll even call it that. And I always get a little bit sideways when I hear when someone says, "Oh, we're going to build this research group," or it's Porsche's research team, or um, and I'm like, "Well, are you going to do something, or are you just going to talk about it?" And if you do something, and you may hire some really great people there, but why you need to connect the dot to the leadership side is that leadership has to endorse this. It has to bring this all the way up the organization and say, team has to be honest with its management and say, look, if we're going to go down this route, it's going to take billions of dollars of hardware and um, a lot of trials to get something that gives us an independent path, independent of Tesla FSD. So it's this thing about leadership and commitment. And I think
Mm,
once you get there, if you get there, then you can go off and have the liberty to build the team. Like, what you don't want. So what I didn't have to do at Rivian, which is one of the things, like when I interviewed at Rivian, my key concern, I had two key concerns, is how are you going to create a unique brand for the product? This is something we're not discussing today, and that was well addressed. And I think you can see that um, Rivian developed an amazingly unique brand for its product. And the second consideration is, do you understand how to do engineering? Do you know how to build this? And it's not saying the words. It's that you would go deep with the commitment to go first principles, to vertically integrate. So Rivian, we not only founded the software teams, but we literally went deep and built the hardware for the car. We built five major ECUs, telematics, and that controlled the infotainment and so forth. And these are deep, deep projects, that are multi-year commitments. And the approach that we took, like, so how did our organization deal with the so-called software development kits and reference platforms? Well, they
mm,
always come at you, right? So, like, for example, let's say that you want to select the Snapdragon um, ARM processor from Qualcomm. It's going to come on some board that's sort of the kitchen sink board, right? So you've got Snapdragon processor, some version of it, and you've got all this I/O, potential I/O channels, and you got RAM, and you got flash, and you got video out, and you got potentially other I/O um, interfaces. And so what they're going to do is they're going to give you this board, this reference board, and you're going to start with that board, and that board is never going to end up in your car. Um, I mean, it potentially could, but it would be first off, they're not producing, they're not mass producing these boards. They're just producing like 1,000 for their, for these SDKs. And what we do with that board is we start prototyping software on that board. Meanwhile, the hardware team starts to select from that main chip, that main CPU, starts to select the profile of what they want for RAM and flash, how much flash, what kind of components, and starts to build another board. And that's the board that ultimately, first comes out in the wrong size, sort of a early
Mm-hmm.
engineering kind of board. It's not really compacted and not really ready for placement in the car. But then the software team, it's sort of a step thing. The software team gets to jump on that board, bootstrap an OS like Linux or whatever you have, Android OS or something, and bring that up. And then once you get that thing, running, you can probably take a lot of the prototype stack that you build at the higher level, the application level, and bring it back down onto that. Um, but what you probably should be hearing in this conversation is these are dedicated teams that have very specialized functions that work together over a long time frame to define this thing and build this thing. And I think the idea that you can just take one of these kits and bootstrap yourself into a running, system in a car, whether it's FSD, like for the focus of driving, or just for the software-defined architecture of the vehicle, is a bit of a pipe dream. It's crazy in my mind.
Yeah, it's a great way to explain it. Yeah, let me share a video of Ford CEO Jim Farley talking about the challenges that he had,
Yeah,
and
good guy, by the way.
He ended up saying the same thing you did at the very end here. Let's watch what he
If I
says.
explain to, the listeners how crazy our software system is and why it's so difficult for legacy car companies to get software right, well, I'll do it very quickly.
Yeah.
So to save probably $500 a vehicle, or let's say 350 quid a vehicle,
Yeah.
we farmed out all the modules that control the vehicles to our suppliers because we could bid them against each other. So Bosch would do the body control module, someone else would do the seat control module, someone else would do the engine control module.
Right.
And we'd have about 150 of these modules of semiconductors all through the car. The problem is the software are all written by, 150 different companies, and they don't talk to each other.
Right.
So even though it says Ford on the front,
Yeah.
I actually have to go to Bosch to get permission to change their seat control software.
Right.
So
Wow.
even if I had a high-speed modem in the vehicle and I had the ability to write their software, it's actually their IP. And I have 150, we call it the loose confederation of software providers, 150 completely different software programming languages, all the structure of the software is different. It's millions of code, and we can't even understand it all. So, that's why at Ford, we've decided in the second generation product to completely insource the electrical architecture.
Right.
And to do that, you need to write all the software yourself. But just remember, car companies haven't written software like this.
Yeah.
Ever. They've never written software. So we're literally writing how the vehicle operates, the software to operate the vehicle for the first time ever.
Yeah.
He concludes that you need to be vertically integrated. You need to have software. You need to have your own engineering team. Yeah.
Well, I have so much to say about that. Yeah. So, I mean, look, let me kind of translate a bit back to what he's saying is that, Legacy is used to sourcing everything from suppliers. And in the early days, that was easy because it wasn't tech, right? It was just like parts, door handles and knobs and things. And these things could easily assemble to other things, and you could spec them in a certain way. And obviously, like you're specing a seat, you're going to want the Ford seat and the Ford Mustang in a certain way, and you obviously have them craft that too, within some limits of their ability. But the software thing threw them. Like it's and he's completely right about what he's saying is if you are now trying to source intelligent objects or technological objects in a car and they all have some kind of code, whether it's low level embedded code that does a small set of functions or it's higher level code that does application. Now you've got all these suppliers, all their code you don't own the code. You don't have the source code. And in fact, what he didn't say is that the suppliers are trying to hold you hostage here to large NRE dollars out the door. What they want you to do is say, yeah, I want to customize that. Oh, great. That's going to cost you another $1 million for that special project for us to fork the source code and do something different. And one of the things that happens here, Herbert, is it creates a nightmare for OTA. And I wrote this paper last year that said, what is a modern software defined architecture? And one of the ways of knowing, it's like the tell, is can you upgrade all of the ECUs, major and minor? Like what is major ECU? Major ECU may be running the whole infotainment system, the screens, the application, but a minor one might just be something that's a door controller, right? That's just opening and closing the door, the windows, or something like that. And there's code there now. So if you can't, through one over-the-air update all of those ECUs from top to bottom, then you don't really have a modern architecture. And so what he's saying is, look, we're not used to doing any of this stuff. Our relationships, the way we've assembled cars, like, I remember someone saying that we had a lot of people that came from McLaren to Rivian, and they're great people, really smart people. But one of the guys said to me, he says, look, we're really into getting a body style and tuning an engine. The rest of the stuff is all just sourced, right?
Yeah, yeah.
And look at the way, say, a Rivian or a Tesla does it. Completely different. Completely different. Now, that isn't to say that either Tesla or Rivian is going to take every component in that car and build it themselves, because that's completely nuts, right? There's a huge supply chain for both companies. But as you start moving up higher and higher, there's two things that you want to do. You want to consolidate function into your own hardware and software platform, if you can, the consolidation. And the consolidation yields like a lower cost system that's more horizontally applicable, right? You means that you can do a lot of different things with it. So you want to kind of bring all that function where you can into that central system. But, there are parts that you're not going to do. And then you have to be very selective about what suppliers you're picking to make sure that that object can live on your network, because it's effectively a network in the car. And that you can actually update that object, because you'd be surprised that when you see a software update from a Tesla or Rivian, there's a lot of subcomponents in the car that either of the vendors or either the manufacturers did not write themselves that have to be updated. And you think that they would last, but no, software is like that, right? You have to update it from time to time. So that was a great video clip, and I think it shows the problem. And what I would say is it shows a secondary problem, which is, how do you go and build those organizations? Literally, how do you build those organizations? Like, you cannot necessarily snap your fingers in suburban Detroit and get a world-class software organization to just kind of exist. You can't do that in Japan. You can do it in Silicon Valley, but it takes that really defined leadership and effort to get there. And so I don't think it works very well.
No, exactly. I appreciate that you explained that very well, very articulately, especially coming from you. You know this so well. So you also said this. You said Tesla's building a moat, NVIDIA's delivering a dream. So NVIDIA is selling the platform, the chips, the SDKs. But as you said, it's just the beginning. The automaker will need to have an engineering team. This is not, they're not handing them anything, really. It's up to the automaker to make something out of it if it's full self-driving. And then they will need to catch up. Is it faster for an automaker today to build an NVIDIA platform, hire the people, and because they were given the tools, that's step one, they now have step one? Or would you say partner with Tesla now?
Yeah, I'd run straight to Tesla easily. I mean, you have to think of the extreme opportunity cost of that time that takes to stand up a team. I mean, you're already in a catch-up mode, right? You're already playing catch-up. And Tesla isn't known to move slowly. And that might just be the understatement of the conversation, right? So not only have they built a world-class engineering team, but they move at an insane pace through amazing leadership that directs them to move at that pace. Um, so, good luck. I mean, I'd rather, and by the way, what do you own in the end? If it's full self-driving, if you're Ford, Toyota, what do you really own in the end if you've sort of done it yourself? I mean, you're still paying a lot for an inference processor from, say, NVIDIA
Right.
for the vehicle. I mean, that's got to cost $800,000. I don't know, some number.
It's
You
a couple
obviously own,
$1,000s.
yeah, you own the
Yeah.
stack,
Yeah.
but then you own the maintenance of that stack, right? You're the one that has to continuously improve it. Um, I think what bothers potentially a legacy automaker, and I've just seen this with what Apple got itself involved in with the latest CarPlay. Okay, it's a very good analogy here.
Hmm.
Um, CarPlay is great for a bunch of these legacy guys because they can't get there, and they want something that just kind of works. And then what Apple's done is they started with this kind of like, this is our design, which is just really the iPhone transmitted on to the screen with some kind of simple application, defined applications. But if you've seen the latest spec for this, they allow the auto manufacturer to change the entire instrument cluster. You know, and what did the auto manufacturer want to do? Well, it wants to create its own brand expression there. And then I think the thing that always happens here is they want to know how much control they have, right? As a large automaker, it's not as if Toyota produces a small number of vehicles, per year. It's a huge number of vehicles. I don't know what, about 10 million per year, I think. I'm not sure. But
Mm-hmm.
they want control over their future. And so I think they worry to a certain extent that when they take on FSD, that they'll get the basics, they'll get the thing that allows the car to autonomously drive, but they'll be left behind and Tesla will progress. I mean, by the way, the second half of this conversation is what we're going to talk about this,
Mm-hmm.
which is Tesla will progress itself forward in a way that potentially they won't get access to those features, right? So that's a worry that is always when you're trying to license something of that magnitude. Like, it's not a small thing; it's a big central part of the vehicle. What can you put your hooks in it? Can you do your thing that sets you off from, say, well, the licensee, for example? Like, you want to do something special or different. Like, let's say Toyota said, just in its own mind, um, we're going to license FSD for the purpose of creating our own robotaxi network. This is our future business. We believe in transportation as a service. We believe the future of Toyota is to stop selling cars and rather sell miles. Let's just say that was their idea. Um, do they believe that if they licensed that from Tesla, that they would have enough autonomy, not to double use the term, but have enough of their own agency to
Mm-hmm.
go off and do the things that
Build on
they
top
want to
of it.
do to build on top of it, and then that's
Mm-hmm.
probably a bit of concern. And I would also say one other thing about FSD licensing in general is I don't think Tesla's really set up to do it. Like, we talk a
Mm-hmm.
lot about it, and I think it makes sense from a lot of different angles. But to become an organization that licenses software and supports that through that's a lot of work. And I know they talk about it, but you have to go seriously deep to get that to happen. And I don't even know, whether it's really in its benefit to do it ultimately, right? I mean, if it does it, it will probably never be deemed a monopoly. If it doesn't do it, it will
Right.
probably monopolize the space. So there's a lot of different angles here that obviously veer more into the business angle than the tech angle.
Yeah. I've been saying just this week, I've been saying that I think Tesla will only partner with 2 or 3 for FSD just to deal with the monopoly conversation.
Yeah.
But then it doesn't make sense. It really doesn't, because it will take all these automakers years and years and years to even implement the FSD for their future vehicles. Tesla probably will get to their mission by creating vehicles faster than expecting a legacy automaker to create vehicles at numbers, at scale.
Yeah. Yeah. I mean, if Tesla can draw in, Tesla can produce an enormous number of cars through cybercab, kind of by the mile, and make that money. There's so much money to be made there. Like, they could exit the auto business from the sales perspective. Well, if they can exit the auto business from a sales perspective, why do they want a license to
Why
the
license? Exactly.
automakers? Yeah, I mean, that's my point of view on it. But nonetheless, I'm just talking about what it would take from the other side to do it.
Yeah, from an automaker. So you explain both pros and cons of licensing with FSD. Can they still maintain some sort of ability to change that or build on top of it? Versus, at the end of the day, you also pointed out that even NVIDIA is a dream. You're buying the tools, you're going to pay them margin, and you still need to build your own software on top of that.
Yeah.
You're catching up. So it's not, just to be very clear, they're not buying autonomous capability from NVIDIA. It's just
Not
the tools.
Yeah.
Yeah.
Yeah. They're building the tools.
Yeah. One of the things you also wrote an article on, which was fantastic, was you called it the connected car. So while all of this is happening, the legacy automakers need to play catch up to be able to get what Tesla is able to do now, with not only the number of vehicles on the road, but the data they're capturing. And then we talked about over the air updates. And you explained very well now. Now I understand why you can't just do over the air updates. Why I just thought it was a very simple feature, but actually it's because it's the connection between all the subsystems and all the modules.
Yeah, it's really hard, actually.
So tell me more about the connected car. This interesting future that Tesla's painting, or you can kind of carry it forward. What are the potential incredible things that can happen? What is the connected car, and what are the potential new features that can come out of that?
Sure. So when I started at Rivian in 2017, the team was called the Connected Car Team.
Oh, yeah.
And the idea was, it was a bit of an eye towards the future, that if you built this, inherently it would be connected, meaning it would be on the internet, you'd be connected to the cloud. You're producing a world-class IoT device, Internet of Things device, right? And so I think it was sort of by calling connected car, we were saying it's aspirational. These are the things that we could lean in and do. And the table stakes stuff in that realm are things like the applications that are like streaming music from the cloud, or navigation, getting map tiles, the satellite map tiles and stuff from the cloud. And what I mean is, like, Rivian Cloud or the Tesla Cloud, the proprietary cloud. And then, of course, there's this whole, by being connected, it allows the mobile app to have a remote experience to the vehicle, kind of a connection to the vehicle. In other words, you can connect to the vehicle from other places, including service or support, internally in an organization. And then it allows the vehicle manufacturer to bring tons and tons and tons and tons of data to the cloud, to be able to take telematics data and deeper data sets and bring that data to the cloud to do all sorts of unique, magical things, and some non-magical things, just basically data analysis type of things. What I tried to do in this particular article is bridge it forward. Like, let's take it to the next step, focus it largely on consumer application, things that the consumer would see as benefits directly, and tie it into FSD. Those three kind of things. And so what I try to imagine here is, with FSD, the FSD process, when you're running FSD in the car, people call that inference, right? It's basically taking the model that's been statically produced by Tesla, it's placed on the car, and then driving data from principally the cameras comes through the system, and it runs through a perception and planning cycles in that inference, and think of them as distinct. And so let's just talk about perception. Perception is the process at which the car, through its visual aspects, meaning the cameras, identify every object, static and dynamic, in the field of view, like everything that's moving. So they would identify this is a stop sign, and they would attach some metadata to it, like it's not moving, but it's here. It is. This is the location in the space, and oh, that's a pedestrian, and the pedestrian is moving, and it's moving at 1.3 miles an hour in this direction, et cetera. So that is the perception data, and the perception data is absolutely intrinsic to how the car is going to actuate its controls to drive itself, like move around objects, et cetera, et cetera. So in a hyper-connected car, a car that you can assume is connected to the cloud continuously, high bandwidth, low latency, right? Two aspects of it, because now, I mean, low latency is a really important aspect because that's what makes video games work, right? Multiplayer video games. Like, you can't have one guy that has a high bandwidth connection but has very low latency. And that's, I think, half the reason that I think it's half the reason Elon plays video games all the time, is he wants to make sure that and he's playing them on his plane 90% of the time, right? So he wants to make sure that Starlink is as low latency as he's demanding. So the thing works. So, now you can start to say, well, what if you took the perception process that's on one car and you teleport it to the rest of the fleet? Now, maybe not the entire fleet, but basically the proximal fleet, that are cars that are in front or behind you on the highway. So let's say you're traveling up a highway and you're perceiving data. So a good simple example of this is, imagine that you're driving up the highway and a service vehicle drops a ladder onto the highway. Okay. Now, what is your car going to do? Your car is going to avoid that. The FSD let's assume it's operating under FSD. And it's important to point out, by the way, the car is still running FSD whether you have it engaged or not. So there's like a shadow mode, right? So in other words, the perception side is running all the time, whether or not you've ever engaged the FSD side. And that's one of the ways Tesla decides what data they want off the car. So anyway, so now imagine that ladder falls onto the highway and your car takes an immediate path around it so that you don't collide into it, right? But imagine it takes that perception data of that object and it transmits it either through the cloud or through a directory through the cloud to other vehicles that are behind it coming up. Now those cars can suddenly build a longer term plan. When I say longer term, it could be a minute downstream or 20 minutes downstream, right? All of a sudden it can build a deeper plan that switches, like, okay, well, don't try to be in lane 1 because it's probably going to get congested anyway. Move to lane 4, right? To go past this ladder on the highway. Now, so that's a simple example. Let's take a much more interesting example. What if Tesla is continuously profiling drivers on the road, or their vehicles, really? And so imagine a huge number of vehicles on the road that are not Tesla FSD, like Toyota Camry running up the road. You have, a Honda Civic. And so now Tesla is looking at the driving behaviors at a very, very, very fine-tuned kind of way. Like, in other words, think of it this way. Imagine that you're looking for an impaired driver. You talk to a police officer, and you say, well, how are you trained to look for impaired drivers? And they say, well, we're trained to do these things. I actually don't know what these things are, but we're trained to do all these little things. And you and I, because we don't really know this, we go, oh, we saw that car really swerve. Maybe it's impaired. But a police officer that's been in the business, it's doing this for years, it's been on the highway for years, like a CHP, is looking at that and saying, oh, just a nuance of move, he's probably recognizes the impaired driver. A vehicle could do that probably 1,000-fold better, right? It could see all those nuances. And another thing it could do by just simply reading the license plate is it could build that profile over a longer period of time, so that if your car so your car comes up and sees that vehicle, and it's not even a real-time thing, but you already have built a profile as to how aggressive is this vehicle, different parameters of how this vehicle might build its operation, so you could build avoidance strategies. And And it sounds a bit far-fetched, but it's really not. I mean, it's all very doable. Um, and let's take it a bit further. At first, I said, well, let's just take the perception data and toss it off the car and allow other cars to use that data. Now, what does that data look like? It's not the raw video, right? The perception data is like, people call it like a vector map, but that may be too technical. But it's basically just a bunch of objects labeled in positions on the road surface, or in the sidewalks and all the surrounding areas. So, so it's basically a distillation or a way to look at the video data and build an interpretation of that data, and then put it in a different form that inherently is lighter weight, right? I mean, lighter weight meaning like if you have 8 cameras feeding the data through the inference engine of the Tesla vehicle, now you've got this perception clip.
Mm-hmm.
It's small number, couple kilobytes of data versus megabytes of. But let's say you have a high bandwidth connection to the car at low latency. What prevents the car from taking all its raw video data, shifting it to the cloud, and allowing an AI process in the cloud with sort of what I call hybrid generative, meaning like reconstruct a bird's eye view of the highway? And I'll give you a very suitable example why you'd want this. How many times has this happened? You're driving down the road, you look at your navigation, you see a big red line, and all of a sudden you slow down to 10 miles an hour. And what do you do? What do you immediately do? You start pinching out that line to see how long is the red line.
Yeah.
Right? I mean, everybody does this. How long is that? Whether you're doing it on your iPhone or you're doing it on your Tesla display, and you pinch it out and you look at it and you go, oh shit, that's 2 miles.
Yeah.
Okay. And here's what you're asking yourself the entire time. Is that 2 miles in 5 minutes or 2 miles in 5 hours? It's literally what you're asking yourself, right? Because you don't know unless you get some other data, like is it an obstruction? Is it slowed down because something fell off a car? What is it? But imagine that you had literally kind of a bird's eye real-time video, a look ahead. And all you had to do was like kind of look at that data. And take it another step further. Why wouldn't you just like Tesla could just allow the AI process to not only build you the bird's eye, what I call the helicopter view of the roadways, basically anywhere, not just like ahead of you, but potentially on your route. But they could also use the AI process to understand what's happening. They could look at it and say, they could reimagine their navigation timing and say, they don't just right now what they do is they're like just kind of project over time based on where they see the slowdown, how much it's going to increase you see these you'll be in traffic for another 10 minutes. But if it's a full obstruction, like an accident and there's fire trucks blocking the lanes, that 10 minutes starts to elongate all the time, right? So it's suddenly
It's
20
always
minutes,
wrong.
30 minutes.
Yeah.
It's always wrong, right? But imagine that the AI in the cloud that's taking in all this aggregate video data looks at that and says, oh, I see signs of movement. I see the ambulance moving away. I see the firemen walking back to their trucks. And
because you got all these Teslas everywhere and they're all feeding the data back up.
Yeah.
And so you're back there, but you've got other Teslas knowing how fast things are moving. This is brilliant. Yeah.
Yeah. So what you're doing is you're basically
scenario, the context.
Yeah. I can understand the context better. Like at first you think, well, I'll use the context, and you do. You want eyes on the context. You always think that as a human you've got a better set of a chance of But also the system can use and build build full context into it and say, well, you're really going to be in traffic for 15 minutes, and we see that suddenly come back to 5, or we're seeing it elongate, and the car's telling you should get off the road. So I mean, these are not crazy ideas, because I guarantee these ideas will be put into place in short order. I mean, when you expect right now, you have, most of these cars are connected. They're connected through mostly cellular. I would expect the Tesla fleet to eventually incorporate Starlink, so that they would have a persistent low latency connection on all pathways, even where cellular isn't covered. And of course, the advantage to Tesla, because they probably pay less for the connection. Because if you wanted to do something like shift full real-time video off the vehicle, there's a lot of bandwidth there. But remember what's happening. Like we're sort of like on a Moore's law basis. We're stepping up to the point where the video coming from this camera looks like a lot of data. Suddenly, a year or two from now, it looks like
It
nothing.
won't be nothing. Yeah.
Looks like nothing.
So
Yeah.
just to be clear, you did point out that one of the features that they're including in FSD version 13, it's like happening now,
Right.
coming
That's
soon.
correct.
It says here dynamic routing around road closures, which
Yeah.
displays them along an affected route when they are detected by the fleet. So this
That's
is
right.
the feature where a
Yeah.
car, a Tesla car ahead of you, can submit the data up to the cloud, bring it back to your car, and now you might know dynamic routing around road closures. There's a road closure because one of the cars up there
Right.
sees it.
What they're doing is they're doing like a baby version of some of the ideas that I'm presenting here, right? They're saying we're going to
Exactly.
take some basic data,
Mhm.
we're going to shift that to the cloud. And by the way, I mean, they may be shifting a lot of data to the cloud. They may be doing that vehicle profiling. I would be surprised if Tesla knows in any geography what the make, model, and year of cars are on the roadway near it, right? I mean,
Yeah,
why
and
wouldn't it?
like you were saying, let's assume there's 10 Teslas in a 2-mile radius, especially my house, my neighborhood. There's all the
Yeah,
they can map every single car that's driving right now in the last 20 minutes in this city that I'm in right now.
absolutely. Yeah,
And by that
no,
point, every
absolutely.
car has been captured because it's like the fleet everywhere and you're driving.
Mhm.
So, and then they can
Yeah.
predict which cars are going to be going where. And then you can do traffic avoidance and,
Yeah. Oh no,
you know,
there's a ton of lean forward on that too, where you could be highly predictive of like utilization, right? Like you could think uh what's the utilization going to look like at the In-N-Out burger
right.
place down the street at 3 o'clock in the afternoon on this Sunday
Right. Even
versus
if
say
your car
last
didn't stop at this,
Sunday.
if
Right.
it didn't stop there, but every time it drives in and out, it's already
Right.
capturing, probably even measuring how many cars are in the drive through. And then
Right.
within, let's say, a month of doing that, it knows by day, by hour, how long that line is in and out.
Yeah. It shifts to like real-time data of pretty much anything because like
Yeah.
let's jump into some of the cybercab ideas,
Mm.
right? So cybercab, would be super cool to have that flooding cities. um they could use the FSD processes and this hyperconnectivity to do some cool things, like I mean like the sort of table stakes thing is optimize the route for pickup, right? Let's say an airport, it's like you could literally, I mean, remember how the cybercab thing is going to work. Someone's going to have an app like an Uber app. Someone's going to have an app. So the app could direct you on a much more granular basis where to meet that car. And it could be optimized for everybody's benefit, right? So it's like you're at airport, say, instead of coming out terminal 3, door 4,
Yeah, it
go to
knows.
terminal 2,
Yeah.
door 9, and we can get you on your way 9 minutes sooner, right? It would know that. And you have only another 300-foot walk or something, right? It would know that. So then imagine that you could take that cybercab and you could like hyper connect it to a series of cybercabs. So if you have like, these things right now are two-seater before, say, robo-van or something like that. You have these two. Imagine you have 12 people in an airport. So you want to order 6 of them and they all kind of come together, and all of a sudden you're operating as a mini kind of fleet down the
Mhm.
road.
And
And
they
then
might even
you could
convoy each other or something like that. So
yeah,
that,
convoying, and they could, it's almost like all the screens
yeah.
could interactively present it as a group. And then you might run
Whoa.
yeah, and then you've got like
Automatic FaceTime, right? Everybody's
yeah,
already
it's
connected
like everybody's connected.
as if you're
You
on
could
one
have one
car.
car be the master where like
Yeah.
the grok process in one car can listen to everyone speak across all vehicles.
Right, right.
Well, how about this
Whoa.
idea? How about this idea, which makes a lot of
Boom.
sense? Just like I said that you could profile vehicles on the roadways, cybercab in cities will probably start profiling neighborhoods, and build dynamic geofences. So, there's a lot of these days, there's a lot of scary neighborhoods in San Francisco, unfortunately. And um, you can dynamically, like right now, I'm sure
Yeah,
Waymo's,
safest path,
yeah,
less
yeah,
likely to
say,
be.
absolutely, yeah,
Yeah.
accosted
Hmm.
or interfered with,
Hmm.
because, and it's not just sort of, you know, it's an entire profile. It's like the entire condition, right? Looking at like maybe the number of pedestrians. Like I noticed, I went to an event in the city and I noticed that there are a lot of pedestrians leaving the event and they already know how to game the Waymos. They just walk right
Hmm.
in front of them. I mean, I'm talking about Waymos that are going 3, 4, 5 miles an hour. They know, people know intrinsically, just walk in front of the thing, it'll stop. So what you'd want is like the Waymo to avoid that area and say, okay, come back another road. And you would see that maybe in the cybercab where they just sort of dynamically aggregate that. And they're doing that quite in real time, as
Hmm.
opposed to just sort of like static geofenced areas. They're like saying, okay, there's an event releasing, there's hundreds of people flooding the road. Um, we're going to optimize pickup 1 block back. We're going to optimize routing 1 block back so that we don't even go down there because there's too many people. Yeah.
These are
It's
great
cool
ideas,
stuff.
Phil. Yeah,
Yeah.
made me think about it. So this brings us back full circle to the first discussion, which is, should an automaker just create themselves, go the NVIDIA route, start step one, uh, find themselves in, pilot stage all the time, or partner with Tesla? And what you've just described here in the second part of this segment of here is that there's a network effect. You want to be part of the group that has these kinds of features,
Right.
that the more you want to be part of that network versus, your own tiny little network that you won't be able to do lots of these potential, the network effect of the more cars there are you're part of, the better the experience is.
Yeah. I mean, that's the thing we're talking about here is, it literally kind of goes a little bit beyond FSD, right? FSD is kind of
Right.
a domain of okay, full self-driving and what does that feature do? But the stuff we're
Mm,
talking about is like the surrounding tissue around that, like features and
yeah.
things that can come out of it and result
Yes.
from it. But
Yeah.
then we have to remember just the intrinsic nature of the tech stack of the car itself. And sort of FSD in a way starts to take over that domain, right? Yeah, sure, you still have your music app, but navigation is forever changed, right? If we talk about some of the features that I have about bringing, say, bird's eye video to navigation, that's happening because of the connected car experience. It's happening because the
Mm,
FSD is bringing in the video and sending it to the cloud, and then some AI processes binding it together and building this, sort of half generative, half real um, view of the road. All of a sudden, like how you see the interface of the car changes pretty dramatically. So I think it
mm,
FSD, which a lot of people can think of it as a feature in a box. I think it gets bigger and bigger. I think the story here that I'm trying to tell is it gets bigger and bigger and bigger,
yes.
and and
Yeah.
it's a weird thing. If you're a Toyota, if you don't play, you're kind of locked out of that ecosystem.
Mm,
If you do play, you do have to worry a little bit about how are you unique. Because car manufacturers, anybody that has kind of their
mm.
own agency towards building a brand or whatever wants to create, what's our unique space. So it's a, what do they say, a sticky thicket for an OEM to decide whether they want to partner
I don't know,
with
Phil.
Tesla.
It's pretty easy. Do I want to die? Do I want to live?
um, in an existential way, or maybe the final form. Yeah, I mean, I intrinsically believe that. I've said to um, many people who listen to me babble that legacy is dead.
Yeah.
It's just a matter of time. So what I'm doing is I'm trying to dive down into their more, material, like what are they doing in the next 2 or 3 years and how do they
Right.
want to preserve themselves? My
Exactly.
personal opinion is that the game is up, it's over with, and that we're looking at, cars that are just, we're looking at a whole different model of transportation service. We're looking
They're not
at,
cars anymore. Mm-hmm.
they're not really cars, and you're looking at a whole tech stack revolution, right? To me, like, where do you find a future buyer of a car if the person has the means? If they're a younger generation person and they have the means, they're going to buy something that's super high tech. That's the lifestyle that they just fit in and what they're adopting and what they're used to. And then the rest of them are going to use transportation as a service. I mean, those are the two places you're going to find yourself. So you will find vehicle ownership, in my opinion, but you're going to find it,
Yeah.
Across a higher sort of socioeconomic strata. Yeah.
Thank you so much, Phil. That was another great conversation. Again, I've said at the beginning, there's no one else like you who actually understands. Worked at a
lot
large
of people say that about me.
Not only did you work at a large automaker, an automaker, you worked at an electric vehicle automaker, and you were responsible for thinking these through. The vehicle UI, the mobile, the cloud, the software stack, building an engineering team, they're having the right culture, having the vision of where we're going in the future, and you've outlined the things that we've just said. So very good conversation. We needed to hear this to understand it's much bigger than just test Toyota choosing NVIDIA. That's just step one. Yeah,
I think so.
Thank you so much, Phil. Yeah. How do people find you again? PBEISEL?
Yeah. P Beisel, PBEISEL at, just on X.
On X.
I hang around X a lot.
We all do now.
So, yeah, we all do, don't we?
Appreciate you.
Okay.
Bye, everybody.
Happy New Year to all your viewers.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.